All right, part 3 of section 6.3. Our objective is to solve exponential equations. So these are actually really fun. All right, to solve exponential equations, we have this new theorem, this new property here. And I have it up here. If a raised to, the power of u equals a raised to the power of v, then u must equal v. Basically, in words, when two exponential expressions, so in our case, the expressions were a to the u and then a to the v, as long as they have the same base, which our base in this case is a, so as long as they have the same base and they have that equal sign in between there, then the exponents are equal. Our first example, we want to solve 4 raised to the 2x minus 1 equals 8 raised to the x. So the first thing we need to do is rewrite each of the base so that they are the same. So we notice 4 and 8, those are both powers of 2, right? 2 squared gives us 4. 2 cubed gives us 8. We're going to use this property. So we're going to rewrite it as 2 squared, so that's the 4 right there. 2 squared raised to the 2x minus 1 equals 2 cubed, that's the 8, raised to the x. Now let's go ahead and kind of simplify this a little bit. So this is 2 raised to the 2 times 2x minus 1. We're allowed to rewrite it like this. It looks a little nicer. Equals 2 raised to the 3x. Because remember, one of our properties of exponents, we have this power right here, like this 2, raised to the power, this x minus 1, or 2x minus 1. So we multiply these guys. Same here with this 3 and the x. We multiply them. So now, there we go. Now we see that we have that same base, that 2. So basically we're dropping that base. We're using that property that, if a to the u equals a to the v, then u equals v. So we can kind of just drop those 2's. This is gone, this is gone. And so we're now left with 2 times 2x minus 1 equals 3x. This we know how to solve. We've been solving these for a while. Go ahead and distribute that 2. So 4x minus 2 equals 3x. And then, let's see, I'm running out of space. 4x minus 2 equals 3x. I would add the 2 over, add the 2. Why don't you go ahead and minus the 3x as well, minus the 3x. So we're left with x equals 2. All right, example 8, this one kind of looks a little weird. We're solving, so it's e raised to the negative x squared equals e raised to the x, all raised to the power of 2, times 1 over e cubed. So first thing we need to do is use our laws of exponents to kind of rearrange and kind of rewrite this. So let's see, e to the negative x squared, we can leave that how it is. But let's rewrite a little bit. So e raised to the x times 2, we multiply those guys together. So that's the same thing as e raised to the 2x. And then remember our negative exponent rule. So if we had 1 over e cubed, is technically the same thing as e to the negative 3. So we have this times e to the negative 3. So then, let's see, more exponent rules here. Same base here. So we're adding our 2 exponents there. So adding 2x minus 3. So we're adding, but because we're adding a negative, it's a minus. Now we have the same basis. So at this point, we can get rid of those guys, those e's, and just worry about negative x squared equals 2x minus 3. Now let's get everything on the same side. So add this x squared over, add the x squared. So we have that 0 equals, write it in standard form, x squared plus 2x minus 3. And guess what? We get to factor this guy. So it goes, what multiplies to give us negative 3, but adds to give us 2. We're going to be 3 and 1. So 0 equals x plus 3, x minus 1 is how that would factor. Set both p's equal to 0 and solve. So x equals negative 3 and x equals positive 1. All right, in the notes I put online, I put a couple additional examples. So the first one, we've got 4 raised to the x times 2x squared equals 16x. So first thing we need to do is rewrite our 4 and our 16 as powers of 2. So remember, 4 is 2 squared, so 2 squared raised to the x times 2x to the squared. 16 is going to be 2 to the 4th power, so 2 to the 4th times x. All right, let's simplify this a little bit. So 2 raised to the 2x times 2 to the x squared equals 2 raised to the 4x. Now, using laws of exponents, remember see a typo. This is 2 to the x squared. There we go. Remember, using our laws of exponents, specifically looking at the left, because this 2 and 2, we're timesing those, so we can add the exponents together. So this is 2 raised to the 2x plus x squared equals 2 raised to the 4x. So now at this point, we can just kind of drop those 2's and then bring our exponents down. So we have 2x plus x squared equals 4x. Let's go ahead and get this set equal to 0. So minus 4x, come up here. So we have x squared minus 2x equals 0. So this one factor, we can pull an x out of both. So x parentheses x minus 2 equals 0. So that means x must equal 0, or x minus 2 equals 0, or x equals 2. Okay, last example. Here we have 3 to the negative x equals 81. So we're trying to think of how can we rearrange 81 to a power of 3. Well, 3 raised to the 4th is 81, so we can rearrange it like this. At this point, drop your 3's, negative x equals 4, divided by a negative 1, x equals negative 4. Quick and easy one.